Hi guys, welcome back. So now we are going to talk about project quality management. This is a dedicated knowledge area in the PMBOK for the quality, and quality is very important. There are so many global organizations who are just specializing in quality concepts, practices, and the standards. So quality is very important. In all the major corporations, there will be a separate department itself which will look after the quality processes and make sure that all the departments, teams, project managers are following quality protocols and the standards. Because when we talk about any project, because if you look at the purpose of a project, its idea is to deliver something of some value. Now, when we are delivering something which is expected to be of some value, there's no point in having that if it is of poor quality. So it's very important to always maintain high standard for quality. And you cannot maintain quality in isolation. You have to have a plan for it. You have to have focus on managing and controlling it. That's why the project quality management is process of incorporating the quality policy regarding planning, managing, and controlling it in the projects. And this also inspire continuous process improvement in the project management practices. These are the sub processes which are happening in this knowledge area. So we have plan quality management, manage quality, and control quality. And as there are so many different industries, even within same industry, you will have variation in the companies. Even within the company, different teams, different departments will have different requirement. Marketing will operate in a different way. Finance is going to behave in a very different way, and so as HR and every other department. So quality measures and techniques are always going to be specific and applicable to the concerned team, concerned project. Now, with so much advance in technology and the overall information management and the level, we already have these standards like Six Sigma, ISO. There's enough information out there about how we should be doing most of these things. So, whether it's operation, technology management, construction, legal, take any domain, you already have quality standards. CMMI level, all of that is for quality. And it shouldn't be done to complete formality. It should be done properly because, as I said, if you just target the formality, if you just, try to finish it, and then the overall quality of the project won't be good, and sooner or later it will be exposed, it will be known to the user, so it will be very bad for you. So you should always focus on the quality and take it seriously. And I have seen there's a lot of confusion around quality and grade. They are not the same concepts. Grade basically you can refer to the something like strength or something like feature. Let's say high grade steel. Now in that case the composition of the steel would be different. It will have certain formula of nickel and tin or iron, whatever it contains, in certain proportion, which will provide it high grade. You can buy the same product with the low grade, like gold jewelries. There is a difference between the gold carat which is used in the making of those jewelry items, or maybe milk where you have different level of cream. So grade is different. It is mostly in the line of the feature. So high grade steel could be of good quality or could be of bad quality. Quality is basically defined by ISO 9000, but in general it means that it should be free of any defects. It should be delivering value with whatever expectation this product or service is expected of. For example, a car. You don't expect a new car, to have any issue. So if you take the car out of parking lot and if it's not starting or having any other problem, it means that this particular car is of poor quality. So that's why quality grades are two very different things. And in a project management is responsible for managing the quality efforts. But as I mentioned earlier, you will have separate teams who can perform audit or perform checks to make sure that that project management team is managing the quality appropriately. And these are the important points which are often used in quality. So it's like prevention and inspection. Prevention is basically means that when you use standard operating procedures to make sure that there are less defects at first place, so we are not allowing them to happen. In fact, I started my career as a trainee in a quality assurance department of a pharmaceutical company. So there, we will first perform sampling on the raw materials which is used in the making of these medicines, cosmetics, and then those raw materials will be passed on to the production department, who will use them to formulate and make these medicines and cosmetic products. So at every stage, they will have to share the sample before a complete medicine is delivered. It goes through certain processes, like they will use the powder to make granules and things like that, and the byproduct, the deliverable at each stage, will be sent to the QA team, and they will perform the testing on that to make sure that the processed material is free of any defects or issues. And then that raw material, that ingredient, is further processed and to produce the completed medicines or cosmetics. And then again, those completed products, those finished products are tested. So you can see that these companies are performing quality management practices at separate level. They have standard operating procedures to make sure that there are least amount of defects or bugs at first place. And I have just used the example from pharmaceutical industry. Similar processes are applied across many other industries, and wherever these processes are not applicable, they use appropriate techniques for prevention, inspection, attribute sampling, tolerance, and the control limits. Means that, as I said earlier, prevention means that keeping out the error from the process. So when we are testing raw material or in process material, we are trying to make sure that our end product doesn't get these defects at first place. Then the finished product is tested, which is the inspection, where the objective is to make sure that to catch any defects even before the customer get their hands on these products. So prevention is done to minimize the number of defects in the product, and inspection is done to make sure that if any issues are there, they are caught before customer use them. Attribute sampling is randomly sampling the material and checking for attributes. And then tolerance and control limits are basically there to make sure that if we have a product where we expect certain variation in the quality. In case of software, in terms of functioning of a software application, we know that we cannot expect if there is any problem. But from a project management standards, we know if there's a tolerance for the number of defects we can have on a particular project. So let's say we have a 2000 hours project, big project. Now in this case, if we get 100 defects, maybe 200 defects, we will have certain tolerance for that. We will accept that this particular project is working fine if the limit is within those defect. That is our tolerance limit. Now if the number of defect goes very high, then we know that there is a problem with the standard processes and the team is doing something wrong. So that's why we have these tolerance and control limits, where we expect certain level of impurity, certain level of defects, but we have a limit for them. In software, the product will be complete without any issue, but in the making of that product, we expect certain level of defects, and we are fine with that. In case of chemicals, there are certain impurities which can be accepted in products if they are within a very specific range. Now don't get scared, your medicines are absolutely fine, but in chemical industry like paint and all other, there are certain chemicals which are found in many mixtures, many compounds, and if they are within certain tolerance limit or control limits, that is acceptable to these industries. Now there are 5 levels of effective quality management. Most expensive ways to deliver the product and customer find the defect. It is said that cost of getting it right first time is lesser than fixing it later. So if you perform prevention and inspection, and get these defects, catch these defects, fix them, and then deliver the product to the customer, your overall cost is going to be lesser. Whereas if you deliver the product to customer, they find out, then you will have to have a formal process to fix that, and that will definitely be more costly, and it will also take a lot of time. It's also bad for your brand. So use testing to identify the defects, fix them. You should have a dedicated QA who should examine the processes, identify the root causes, which is represented by RC here, and fix that. And quality should be incorporated in the planning and designing of the project. It's better to promote a culture of quality so that all the team members are aware of the concept of quality, they understand its significance, and they contribute towards it. Because a lot of time there are a lot of professionals who just treat it as some kind of burden, additional activities which they think are not important, but these are very important. And project management should work on creating the awareness around the project quality management. These are the factors. Like any other knowledge area, here we have these factors like policy compliance and auditing, standards and the regulatory compliance. Chemical, pharmaceutical industries, they are highly regulated industries, so they perform far more checks than, let's say, a regular IT company, where they will have audits, but the number of audits are going to be lesser. Then continuous improvement, stakeholder engagement, all of these factors contribute towards customization for the quality. And this is our first sub process within quality management. So this is plan quality management. It is the process of identifying quality requirements and the standards. It documents how project will comply to project requirements, quality requirements and standards. This process is performed once or at predefined points in the project. If you need, you should have quality driven, quality specific requirements. These are called quality requirements. Like, you can have performance requirements and performance testing to ensure that your software, your application follow certain performance standards. For inputs, we have project charter, project management plan, risk management plan, stakeholder engagement plan, scope baseline, project documents, assumption log, requirement documentation, requirement traceability matrix, risk register, stakeholder register, enterprise environmental factors, organizational process assets. And I keep on talking about these input output diagram because sometimes you not only need to understand how things are flowing, that is in the form of input output and the techniques which are used, but also direct questions can be asked about these in interviews, in PMP exams. So that's why it may look like repetitive, because in all sub processes I will talk about them, but please note that these are important and we need to cover them. As we are talking about quality, so our project management plan is going to be input here along with project charter and the project documents. And enterprise environmental factors plays a big role in impacting quality, and so as organizational process assets, because as I mentioned earlier, organizations can have their own quality standards, they can follow ISO standards, and they may have their own offices dedicated towards quality practices. So these things will play important role in the form of OPAs, and project management will need to make sure that they are following those standards. For tools and techniques, we have expert judgment, data gathering in the form of benchmarking, brainstorming, interviews. Brainstorming interviews are, where you are interacting with the stakeholders. Interviews one-to-one, brainstorming in group. Benchmarking is very important. In fact, it's very popular across software industry, where we compare the performance of our product with other product or deliverables to, have an understanding about the industry standards. So, and our deliverables should be following the industry standards. Then we have the data analysis for cost benefit analysis, cost of quality. Cost benefit analysis is basically a financial analysis where we look at the cost and the benefit of the solution. Usually it is done to find out the best alternative. So let's say if there are more than one alternative, we will perform a cost benefit analysis to see which particular solution should be opted. Cost of quality is also known as COQ. In this technique, basically, we have three components. One is prevention cost, and second one is appraisal cost, and the third one is failure cost. So prevention cost is basically related to the cost which is required for prevention of poor quality in the products or the deliverables. Appraisal cost means to the cost of a cost which is needed for evaluating, measuring, or auditing, and it also includes the testing. So idea here is to find a prevention and appraisal cost, which is useful in avoiding the failure cost. For example, if a functionality doesn't work, now not working is failure, and the cost of it is $1,000. Now, if our cost of preventing and appraising it is more than $1,000, then it's better to go with the failure cost, because the failure cost is less than the cost of preventing or appraising it. So approach here is to make sure that we don't overspend. If the change is not worth it, we should manage without the functionality which is in the question. And it is very commonly applied in software projects, in many other projects. In fact, you will get these change requests where certain functionalities probably is not working or missing, and the first thing we determine to check if the change is worth it. And then we have decision making, which is multi-criteria decision making, which is similar to prioritizing based on the features. And then we have the flowcharts for data representation. They basically represent the sequence of steps and the branching possibilities. So it's like user hits the submit button, it takes to the next page, and then it takes to the third page. So all of that sequence is represented through flowchart. Logical data model is again a visual representation, but it happens in the form of data. This is specific to the organization, so every organization will have their own standard for data visualization and how data is flowing. In matrix diagrams, basically different columns and rows are used. It's like a spreadsheet where you will have different factor, causes, and their objective, and they basically identify the metrics, quality metrics, which should be there in order for the project to be successful. And then of course we have test and inspection planning. And all companies, whether it's software, pharmaceutical, or any other industry, they will always have QA testing departments, testing teams who will perform the testing of the product before it is delivered. And then we will have the meetings. For output, we will have the quality management plan, quality metrics, which will be basically your KPIs, key performance indicators. So you will know the skills and the parameters at which a project should be evaluated. Then any project management plan updates, risk management plan, scope baseline, project documents updates will include lesson learned register, requirement traceability matrix, risk register, stakeholder register. And for the application, we will have project document updates like quality metrics, lesson learned register, requirement traceability matrix, risk register, and stakeholder register. So that's it for now. In the next video, I will talk about rest of the sub processes. Thank you.